In this screencast, we're going to be looking at tsunamis and in particular what they are, as well as a case study looking at the causes, effects and responses to a tsunami. Now, tsunamis are usually triggered by earthquakes. The crust shifting is the primary effect. The knock-on effects, the secondary effects, remember, is the displacement of water above the moving crust. So this is the start of the tsunami. Now a normal wind-driven wave may have a length of about 100 metres, as you can see on this diagram here, between the crests, but a tsunami may be, as it says here, 200 kilometres apart. That's a big difference in the length of those waves. The heights also greatly differ. So 2 metres for a normal wave, between the crest here and the bottom there, compared to 1 metre for a tsunami when it's out at sea. So you can see the wave isn't very high when it's out at sea. However, when it reaches the coastline, then the height can increase up to 30 metres. Tsunamis can move at speeds of around 800 kilometres an hour, rapidly approaching the coast almost unnoticed, and as they near the land, they slow down, they reduce in length, as you can see here the wavelength shortens between the two crests, and the height, as we already mentioned, increases up to maybe 30 metres. Now our case study of a tsunami is going to be the Tohoku tsunami in Japan 2011. So it wasn't long ago, and I'm sure that you'll have seen that on the news. However, in the space of just a few years, powerful tsunamis have caused widespread destruction and huge loss of life. On the 26th of December 2004, there was a massive earthquake in the Indian Ocean measuring 9.3 on the Richter scale. It triggered a tsunami that was up to 25 metres high that swept onshore, killing an estimated 220,000 people in Indonesia, India and Sri Lanka. Now, our case study, as I said already, is the Tohoku tsunami in Japan. And on the 11th of March 2011, a very powerful earthquake measuring 9 on the Richter scale occurred about 100 kilometres east of Sendai on Honshu, Japan. In just 30 minutes, a wall of water up to 40 metres high hit the coast of northwestern Japan. It was followed in places by up to 9 additional waves of up to 10 metres in height. Some 3,000 kilometres of coastline were affected by the waves, which tore through coastal defences and inundated the coastal plains. This is a photograph here showing us the impact of the Japanese tsunami and how far that wave actually travelled inland, just wiping everything out in its path. So what caused this actual tsunami? The earthquake that triggered the tsunami occurred at the destructive plate margin, where the Pacific plate is being subducted beneath the North American plate. So here's the North American plate here, here's the Pacific plate, and where this plate is being subducted, remember, sinks down underneath the North American plate, this is where the earthquake actually happened, the epicenter of the earthquake. Now, scientists believe that a segment of rock some 200 kilometres in length slipped suddenly, resulting in an upwards flick of the Earth's crust by between 5 to 10 metres. It was this sudden uplift that triggered the tsunami. So if you look in more detail, here we see North American plate and the Pacific plate. One tectonic plate is dragged beneath the other. So Pacific plate in this case, as you can see, it's going down. This caused the edge of the plates to flex and deform, causing pressure to build up over time. Secondly, the massive stresses eventually caused the plate to snap back. So this snaps back, as you can see, it's bending here, but then it snaps back into place, and what it does, it displaces a vertical column. So here you can see this vertical column of water which causes a tsunami. Third of all, at the fault line, the tsunami is merely a ripple. So you can see just a tiny little ripple here, but as it approaches land, it gains in height. So at E here, the wave's much bigger, and as it approaches that shallow water, it slows the wave down and becomes higher in height, as we looked at earlier. Now, as you can imagine, a tsunami of this size has a massive effect on the place that has occurred. Over 20,000 people were actually killed as the waves swept up to 10 kilometres onshore. The high death toll was due to the power of the surge of water which overtopped tsunami defences. So they did have a wall there, but it just went over the top, and flooded areas thought to be safe from a tsunami. Some 500 kilometres squared of coastal plains were inundated, destroyed farmland, settlements and communications. The port of Sendai was virtually destroyed. A total of 200,000 buildings were damaged or destroyed by the earthquake and tsunami. Ruptured gas pipes led to fires that raged for several days. Explosions occurred at the Fukushima nuclear power plant as seawater overtopped the flood defences. There were considerable concerns about nuclear contamination and the possibility of a meltdown as the cooling systems failed to operate. And this was on the news kind of day after this tsunami had occurred. Electricity was cut off in almost 6 million houses, and over 1 million people were left without running water. Heavy snow, roads blocked by debris and landslides, and over 1,000 aftershocks hampered relief efforts. In some areas, stocks of food, water and medical supplies ran low. Stock markets around the world fell over concerns about Japan's rising debts in the face of billions of US dollars worth of damage. So finally then, what were the responses? Well, over 100,000 Japanese soldiers were deployed in search and rescue. They distributed blankets, water and food to the people affected by the disaster, so a short-term response. Specialist search and rescue teams were flown into the area from overseas. An exclusion zone was set up around the Fukushima nuclear plant and people were evacuated from the area. Again, all short-term responses. In the longer term though, a huge rebuilding and reconstruction program is planned involving houses, infrastructure and communication systems, so roads, railways, etc. Port facilities need to be rebuilt, the system of tsunami defences need to be reconsidered, and may well be extended in height beyond the standard 12 metres that is currently the accepted level. So, short-term responses and long-term responses. Now you've watched the video on tsunamis or the screencast, you now need to log on to Edmodo and have a go at the quiz.